In this note, we are going to be focusing on rational functions. My hope is that by now you have graphed the 5 rational functions in the previous note, just to remind yourself about what they look like and become familiar with them again. So the first thing that we're going to be talking about for rational functions are the asymptotes. So just a quick little reminder in red there, please make sure that your equation is in fully factored form. That's going to make this a whole lot easier. When we are finding our vertical asymptotes, you need to do the exact same thing that you've been doing. You're going to set your denominator equal to 0 and solve for x. And then another little reminder there, remember if your denominator cannot equal 0 because that would imply an undefined function. Our horizontal asymptotes are a little bit different. So remember, we're going to be taking a look at what happens as x approaches infinity or x approaches negative infinity. So if the limit as x approaches infinity or as x approaches negative infinity is some value of L, then the line y equals L is our horizontal asymptote. All right, our first example says find the vertical asymptote. It's missing an s, it should say totes, for y equals 3 over x squared minus 4. So like I said on the previous page, whenever we have a question like this, it should be in fully factored form. So I'm going to go ahead and do that. So this is just a difference of squares in my denominator, which factors to x minus 2 and x plus 2. Now when I'm finding my vertical asymptotes, I know that I need to set that denominator equal to 0 and solve. So when I do that, I'm going to be getting equals positive 2 as one of my vertical asymptotes and x equals negative 2 as the other. So one quick thing that I wanted to mention, once we have these vertical asymptotes, we want to take a look back. In this case, our numerator doesn't have any of these factors, but if it did, then we would have to remember that that would no longer be a vertical asymptote. It would be a point discontinuity or a hole. All right, example 2 says find the horizontal asymptote, or totes, for f of x equals 3x squared over x squared plus 1. You may remember some tricks to do these, and I'm okay with you using those as well, but I am going to show you all of the work right now. So the first thing that we're going to do is start with the limit as x approaches infinity of our function 3x squared over x squared plus 1. Now if you think back to when we were doing limits, there were some tricks that we talked about or that you practiced. So for this particular question, what I would do is I would divide each of these terms by the highest power. So if I do that, I'm getting the limit as x approaches infinity. My highest power is x squared. So 3x squared over x squared over x squared over x squared plus 1 over x squared. I'm still going to keep my limit. I'm just going to simplify. I'm not plugging anything in yet. The numerator can just simplify to 3. The denominator will simplify to 1 over 1 plus x squared. At this point, I can go ahead and I can plug in my x of infinity, and I'm going to be getting 3 over 1 plus, and 1 over infinity goes to 0, so 0, which is going to be 3 over 1, which is just 3. So what we've just figured out is that we have a horizontal asymptote at y equals 3. So example 3 says sketch y equals 6x over x squared minus 4 by finding the asymptotes. I am going to do my vertical asymptotes first, and remember what we're doing is we're setting our denominator equal to 0. Again, I have a difference of squares. I could factor x minus 2, x plus 2. X is equal to positive 2, or x is equal to negative 2 are my vertical asymptotes. And then in terms of my horizontal asymptotes, I am going to be setting up the limit like I did on my previous question. So the limit as x approaches infinity of my function 6x over x squared minus 4. When I look at this question, I am going to do the exact same process as the previous example. So I'm going to be dividing each of these terms by the highest power, which in this case is my x squared again. So the limit as x approaches infinity of 6x over x squared over x squared over x squared minus 4 over x squared. Again, I'm keeping my limit notation because I'm not plugging in infinity yet. I'm just simplifying. 6x over x squared is 6 over x over 1 minus 4 over x squared. At this time, I am going to be plugging in my x of infinity, so I am not writing limit notation anymore. 6 over infinity we can simplify to nothing or 0 over 1 minus, and again 4 over infinity does simplify to 0. So I'm going to be getting 0, and I know that I have a horizontal asymptote at y equals 0. At this point, we can take all of this information, plug that into our graph. We'll be able to get those dotted lines and then see what happens from there. All right, so at this point, we are able to get these dashed lines in for our asymptotes. So just to remind you, we had a horizontal asymptote at y equals 0, and we have those vertical asymptotes at x equals -2 and x equals +2. Please don't underestimate the value of a good chart. So what I'm going to do is I'm going to plug in some numbers that are around my vertical asymptotes. There we go. Undefined at -2 and undefined at +2. But if I plug in numbers very, very close, I should be able to see whether we're going to a positive infinity or a negative infinity. If I plug in -2.9 to my original function, I get -300 and something. So that's basically telling me that at this -2 asymptote, I know that my sketch is going towards negative infinity. And if I do the opposite side, if I approach it from the right, so coming in at -1.99, I get 299 point something, which tells me, and I should have used a different color here, I'm really sorry, which tells me that this is going to positive infinity. Now, I know that at 0, 0, if I plug in 0 to my original function, it does give me a result of 0. So I know that that is my intercept right there. I'm going to do the exact same thing for my vertical asymptote of 2. If I approach from the left, so at 1.99, I get -299.2, which means that it is going to be approaching negative infinity. And if I approach that 2 from the right, I get 300.75-ish, which means it is going to approach positive infinity. Now remember, this is just a sketch. There's nothing very accurate about it at all. We are just trying to see some of the behavior going on. If I did want to double check, I could just double check these near my horizontal asymptote, I guess I'm going to say. So if I plugged in a larger x value, so an x value of 100 and a very small x value, so a -100, again, these are just chosen values. Maybe you want to choose 200 or 300 or 400. It really doesn't matter. I'm just picking a large x value and a very small x value. So if I plug 100 into this original function, I'm going to get a very, very small value. And this makes sense because I have that my graph is approaching 0 when I get higher into the higher x values. The exact same thing happens if I plug in -100. I get a really small negative number, which again makes sense with what I have drawn here. So this is just another quick check to make sure that your sketch looks the way that it should.